Hey there, welcome to the Wally Code. Today, we're going to learn how to make a Flappy Bird in Unity. Flappy Bird is a simple yet challenging game. Your goal is to navigate a bird through a series of plants without crashing. If you're new to game development, don't worry. We'll guide you through every step of the process. And if you have any questions, feel free to ask in the comments down below. Don't forget to subscribe to my channel and turn on notifications by clicking the bell icon. This way, you'll stay updated with all the latest tutorials, tips, and tricks in game development on Wally Code. And make sure to tune in to the next video, where I'll guide you through implementing ads and publishing this game on the Play Store. To begin, let's create a new project. Click on New Project to get started. Next, select your desired Unity version. For this tutorial, we'll be using Unity version 2021.3.33. Choose the 3D sample scene URP template. Now let's name it Flappy Bird 2. Uncheck the box to connect to Unity Cloud. Now, select your cloud organization. If you're new to Unity or don't have an organization yet, you can easily create one by visiting your Unity account. And finally, click on Create Project to start your new project. First, let's create a new folder to organize our files. Right-click in the project window, hover over Create, and select Folder. Name the folder URP. Next, let's create a new empty scene for our game. Go to File and select New Scene. Now, let's set up our project. Navigate to File, Build Settings. In the Build Settings window, remove the sample scene by clicking on it and pressing the Delete button. Next, select the platform you'll be building your game for. For this example, I'm choosing Android, but you can select any platform that suits your needs. Finally, click on the Switch Platform button to apply the selected platform settings to your project. Now, let's configure the player settings for our project. Enter your company name, product name, and app version. Next, let's choose a default icon for our game. In the icon settings, you can customize icons for different APIs to ensure compatibility. For resolution, Unity offers options for rendering outside the safe area, but I prefer to implement my own code for more control. Optimized frame pacing in this Unity version can sometimes lead to crashes on certain devices, which may trigger errors visible on the Google Play Store. To mitigate this potential issue, I prefer to turn off optimized frame pacing. Blit types also sometimes lead to crashes on certain devices, which might result in errors appearing on the Google Play Store. To address this potential issue, I recommend setting blit types to auto. Choose the allowed orientations that best suit your game. In this case, I'll stick with landscape mode and uncheck portrait. Customize your splash screen by adjusting the background color and adding your logo. Please note that the Unity logo cannot be removed without a Unity Pro license. Now, let's handle some crucial settings. Uncheck Auto Graphics API. And set the texture compression format to EDC2, commonly used for Android. Set the minimum and maximum API levels according to the Android versions your game supports. Choose IL2CPP as the scripting backend and ensure ARM64 support is enabled for broader device compatibility. We'll cover setting up the key store in the upcoming video, so be sure to stay tuned. Now, let's head over to the Graphics tab on the left. Here, under Scriptable Render Pipeline Settings, you can choose a render pipeline asset. Although Unity provides presets like low, medium, and high, feel free to customize them to suit your needs. In the Quality section, you'll find presets optimized for different platforms. For VSync count, make sure to select Don't Sync to enhance performance. Turning off VSync minimizes latency, while turning it on can provide smoother visuals but may introduce input lag. As for the remaining settings, we'll explore them in a future video. In the Text Mesh Pro section, locate TMP Essentials. Simply click on Import TMP Essentials to integrate it into your project. With that complete, go ahead and close the window. Your project is now finally configured and ready to go. Let's organize our project by importing all the textures we'll need. First, create a new folder named Textures and move all the textures into this folder. Once organized, select all the textures, head to the inspector, and set their texture type to Sprite. Don't forget to apply the changes. Now, it's time to import additional assets such as fonts, the skybox gradient shader, sounds, and scripts. You can locate all the necessary files in the video description below. For our project, we'll be using some plant models from the Megatoon Desert Pack. We'll also utilize bird models and animations from the Cartoon Birds Animated Pack. For text elements, we've chosen the Lolita one and Ubuntu fonts, both conveniently accessible on Google Fonts for free. All download links are provided in the description below for easy access. Next up, let's adjust the background color using the Skybox Gradient shader we've imported. Go to Skybox Gradient folder and drag the Skybox material directly into the scene. Then, head over to the inspector window where you can customize the top and bottom colors to match your scene. Now, let's proceed by importing both assets into our project. Let's start by clearing any warnings from the console to ensure our project is error-free. Next, adjust the game window for better visibility. Navigate to the Cartoon Birds Animated Pack. Within the Prefabs folder, select any bird. You may notice it appears pink. To resolve this, head to the Materials folder, Select all materials and click Edit. Rendering materials. Convert selected built-in materials to URP. Now, drag the bird prefab into the scene and unpack it completely. Reset the bird's position and adjust the camera angle so the bird is facing right. Select the bird's skin mesh and apply a different material if desired. Position the bird in the center, facing right. Create a 3D plane as the ground. Rotate it 90 degrees. And apply a texture. If the texture appears blurry, select it and in the inspector, under wrap mode, set it to repeat and apply the changes. Select the ground, go to the material and under shader, choose unlit texture. Adjust the tiling as needed. Position the ground at the bottom of the scene. Rename the bird to Player Bird. Now, let's add some mountain sprites to the scene and adjust their positions. Create an empty object called Clouds. Then, add sky sprites to the scene and adjust their positions. Apply some transparency to the sky if desired. Move the sky sprites into the cloud's empty object. Create another empty object named barriers. In the Megatoon Desert Pack, navigate to the Prefabs folder and select Plants. Navigate to the Material folder inside the Toon Desert Pack. Select all materials. Then go to Edit, Rendering, Materials, convert selected built-in materials to URP, and proceed. Now, head to the Plants Prefabs and drag some plants into the scene. Feel free to choose any plant you prefer. Unpack the plants completely from the prefab and move them all into the barriers object. Resize the plants using the scale tool and adjust their positions. You can also rotate them if necessary. Select the cloud and duplicate it. Then apply transparency to the duplicate cloud. Once done, the scene should look okay. To keep things organized, create an empty object named Environment and move all objects into it. Disable the barriers object for now. Duplicate the barriers object and rename it Plants. Now enable the barriers object. Since we only need 2 plants, delete the rest in barriers. Reset the position and scale of the plants. We'll use these plants in the game where the player can navigate between them without hitting them. Create an empty object named Target1. Hide the other plant and move this plant into the Target1 object. Set the x-axis to 0 and the y-axis to -1.5. Duplicate the plant. Rotate it 180 degrees. And move it up. Ensure both plants are aligned center. Remove the box collider component from the plants. We won't be using the collider directly on the plants because, as you can see, the collider isn't straight. Instead, we'll create a separate object for the collider. Create an empty object named Top. and add a box collider component. Set the position and scale to match the plant. Duplicate the top object and name it down. Align this object with the other plant. Now duplicate down object and name them target. This object will act as triggers to give score. Move them in between the plants. Duplicate the Target 1 object and name it Target 2. Replace the plants with other plants and align them with the existing ones. Repeat the same steps as before. Now, let's add tags to the collider objects to categorize them for specific functionalities in our game. Select Untagged from the Tag drop-down. Click Add Tag. Then click plus icon to create a new tag named Barrier. Save it. Add another tag named Target. Select the top and down object, and then assign the barrier tag to the objects. And also, remember to check the Trigger checkbox in the collider. Similarly, assign the target tag to the target object. Do the same for the other target object, Target 2. Let's adjust the height of the ground. Save the scene, then create a folder named Scenes. And save the scene as Flappy Bird. Create a new folder named Prefabs and drag the Target 1 and Target 2 object prefabs into this folder. Delete the barrier object, then create an empty object named Spawn Barriers and set its position to 10. Now, the scene is ready. First, create a new empty object in the scene and name it Game Controller. This object will handle the game logic. Next, create a canvas in the scene and name it UI Manager. This canvas will contain all the UI menus. Now, under the Canvas Scaler component, change the UI Scale mode to Scale with Screen Size. Set the resolution to 1920 by 1080 and adjust the match width or height to 0.5. With the canvas set up, let's create the main menu interface. Create a new UI object under the canvas and name it Home UI. This will be the main menu screen where players start the game. Now duplicate. Name it Gameplay UI. Again, name it Paused Game UI. Again, name it End Game Menu. Now that we have our basic menu structures in place, we can start customizing each menu to fit our game's theme and functionality. To create a logo image, go to UI and select Image. Rename it to Logo. Add your image. Click Set Native Size. Setting the native size ensures the image appears in its original dimensions. Now resize and reposition it as needed. To add a button, select Button from the UI options, then rename it to Play Button. Let's create an image and name it Leaderboard. Choose any color you prefer for the image. Now, let's create a text mesh pro text. Right? Old time. Select a font. Set the size to auto with a minimum size of 5 and align it to the center. Adjust the color to your liking. Lastly, set the font style to bold. Duplicate the Text Mesh Pro text component to display your old game time. Now, duplicate it again. Replace name with total score. And write total score. Disable the Home UI to hide it from view. Create a new image named Score Panel. And place it in the left corner. Adjust its position and change its color. Then, add a Text Mesh Pro text component to display the score. Duplicate and name it Timer Panel. Place it in the center and adjust its position. Duplicate and name it Paused Button. Remove the text and add an image icon. Set the image's size to native size and add a button component. Set the transition to none. Disable the Gameplay UI to hide it from view. Let's create a new image named BG. and stretch it to cover the full screen. And change its color to black and adjust the transparency. Create a text object. Game paused. Adjust its position. Now, create a button named Resume Button. And add a sprite to it. Now to fix the border of button image. Select the image and open the sprite editor from the inspector. Enter 512 for all borders. And apply the changes. Drag the image into the button and adjust the pixels per unit multiple. Now change the color. On the inside the button, select the text and change it to Resume. Choose a font. Set it to auto size. And change the text color to white. Duplicate the button and name it Restart Game Button. Duplicate it again and name it Exit Game Button. Adjust their positions. Change the text. And color as needed. Disable the paused game UI to hide it from view. Now, duplicate the BG object and move it to the in-game UI. Duplicate the text and restart button as well. And change the text to Game End. Inside the button, remove the text and add an image with an icon. Now, all menus are created. Now, select the play button and add a shadow component. Now, select the game controller object, add a component, and attach the game controller script. I've already created a script, so I'll attach it directly to the game controller object. In the UI menu section, we define references to different menu panels, such as the Home menu, Gameplay menu, Paused menu, and Game End menu. Moving on to the UI text elements, we store references to TextMesh Pro components responsible for displaying information like total score, old time, current score, and game time. The game controller script also holds references to crucial game objects, like the player, spawner, and other main game elements. As we start the game in the Start method, we ensure to set the initial state of UI elements and game objects using the setUIState and setObjectState methods. When the play button method is triggered, it seamlessly transitions from the Home menu to the Gameplay menu while enabling essential game objects, like the player and spawner. To track game progress, the Start Game Timer method initializes the game timer, resetting the score and time display. During gameplay, the Update method continuously updates the game time text as the game progresses. To maintain a clean game environment, the Destroy Existing Barriers method removes any existing barrier objects from the scene. Handling game termination, the Endgame button method triggers the Game End event, displaying the Game End menu and saving the old time and total score. The Restart Scene method restarts the current scene. The Pause Game method halts the game timer and displays the paused menu, while the Resume Game method resumes the game seamlessly. In case the player decides to exit the game, the Exit Game button method gracefully handles game closure, whether in the editor or in-game. Additionally, we ensure persistent score and time tracking using player prefs, with methods to load and save the total score and old time. Lastly, the Increase Score method dynamically increments the score, while the Open Link method opens URLs. Don't forget, you can access the full script in the video description below, allowing you to follow along and customize it to your game's needs. Now, let's assign all the necessary objects to the script. To organize our objects efficiently, create an empty object named Main Menu Objects here to contain all the objects displayed in the Home menu. Similarly, create another empty object named Gameplay Objects here to contain all the objects displayed during gameplay. Now, make sure to assign both of these objects to the script for proper functionality. Now, let's set up the player object. First, add a rigid body component. And ensure Use Gravity is unchecked. Next, add a box collider component, and check the Is Trigger box. Adjust its position and size accordingly. Then, set its tag to player. Finally, attach the player controller script to the player object. First, we have some variables. Jump strength determines how strong the player's jump is. Gravity force represents the force of gravity acting on the player. Tilt angle controls the angle at which the player tilts during movement. Min Y position and max Y position define the minimum and maximum Y positions for the player. We also have a reference to the game controller script and an audio source for playing sound effects. In the onEnable method, we reset the player's Y position to 0 and initialize the movement direction. In the update method, we check for jump input using the space bar or left mouse button. If detected, we set the movement direction to move upward. We then apply gravity to simulate falling and update the player's position accordingly. The player's Y position is clamped within the defined limits, and the player is tilted based on movement direction. The onTriggerEnter method handles collision events. If the player collides with a barrier, indicating a hazard, the game ends. If the collision is with a target, representing a collectible, the player's score increases. And that's the player controller script, controlling the player's behavior and interactions within the game. Now, assign the game controller to script. Add component, audio source, and attach to script. Uncheck the play on awake. Now, let's add function to buttons. Select play button. Under on click, press plus icon, drag game controller script, and add function play button. Same process for paused button. Select function paused game. And repeat this process for other buttons. Now done, press play to test the game. Let's first remove animator. And remove mesh collider. And add box collider. Adjust the scale. And checkbox is trigger. Now press play. Now player jumps when you press, and if player touch with ground, then game end. Now select Spawn Barriers. Under the Gameplay Objects here, add Component Object Spawner. First, we have some variables. Objects to spawn, an array of prefabs that the spawner can spawn. Spawn rate, the frequency at which objects are spawned. Spawn height range, a range of heights within which objects can be spawned. Randomize rotation, a boolean indicating whether to randomize the rotation of spawned objects. In the onEnable method, we check if there are prefabs assigned to spawn. If not, we log an error and disable the spawner component. If there are assigned prefabs, we start spawning objects at the specified rate using invoke repeating. The onDisable method stops the spawning process when the spawner component is disabled. The spawnObject method is responsible for spawning objects. It randomly selects a prefab from the array, calculates a spawn position within the specified height range, and determines a spawn rotation. Finally, it instantiates the selected prefab at the calculated position and rotation. Now select Objects to Spawn, and go to Prefabs folder to assign both prefabs to script. Now select both prefab and drop in hierarchy. Select both and add component barrier. First, we have two public transform variables, top transform and bottom transform. These are references to the top and bottom parts of the barrier. Next, we have a public float variable called movement speed, which determines how fast the barrier moves across the screen. In the start method, we calculate the left edge of the screen in world coordinates. This is used to determine when the barrier has moved out of view. In the update method, we continuously move the barrier to the left by adding movement speed multiplied by time, delta time, to its position vector in the direction of vector 3.left. Then, we check if the barrier has moved out of view by comparing its x position to the left edge variable. If it has moved out of view, we destroy the barrier object using destroy game object. That's it for the barrier script. It controls the movement of the barrier objects in our game, ensuring they move smoothly across the screen and are destroyed when they are no longer visible. Now open each prefab and assign top and bottom object to barrier script. And apply changes. Now delete prefabs and hierarchy. Reset position to 0. Let's fix those. Add both prefabs to hierarchy and adjust scale. First, let's ensure that the time and score are saved properly. Now, let's add music to the game. Select the game controller object and add an audio source component. Then, go to the sound folder and drag the music file into the audio source component. Make sure to set the loop option so that the music continues playing. Now, let's add sound effects to the player bird. we reference an audio source. And call a function to play based on the barrier tag. Similarly, we'll do the same for the target dot. Let's press play to test the changes. Now, let's add animations to our game. Select the player bird object. We need to add an animation controller. So navigate to the Cartoon Birds Animated Pack folder, then to the Animation folder. Here, we already have animations available. Open the Bird AC controller. You can see all animations already added to the controller. Now let's drag a bird prefab in scene. Change the material of the bird skin. Turn on the emission. Add a texture and change the color to white. Press play to test. Now you can see the controller playing each animation one by one. Now, let's choose the animations we want to use. You can select and play each animation by clicking on it. First, let's duplicate this controller and name it Flappy Bird. Open it and delete extra animations. And remove arrows. Now, arrange the animations. Start with idle and set it as the default state. Create new transitions. I'm also adding the idle animation in between other animations for better transitions. Do the same process for the remaining animations. Now, drag the controller into the animator. Let's play to test animations. You can also see in the animator which animation is playing. Now, let's add an animation to the player object. Duplicate the Flappy Bird controller and name it Player Bird. Then open it. Delete all animations except Fly No Offset, because we only need one animation for this, which is Fly No Offset. Now, select Fly No Offset and duplicate it. Select the duplicated animation replace the old animation with this one, and turn on loop time. You can see the animation looping. Select the player and drag the controller into the player animator. Play. Now, move the bird to the main menu objects here, so it doesn't show during gameplay. Now, let's add animations to the clouds and mountains. Go to the animation window, create a new animation, and name it Clouds Animations. This animation will animate the clouds moving in left and right directions. Let's start. Click the record button. Set the initial position of the clouds at 11. Then, in 300 frames, set the next position to -11. Now, select the clouds and repeat the same steps. You can customize this based on your scene. Now, you'll see the Clouds Mountains controller created. You can also see the Clouds animation in the animator. Next, we're going to decrease the speed of the animation. Make sure loop time is turned on. You can adjust this based on your scene. Now, let's set up lighting in the scene. Select the directional light and set its intensity to 2. Then, go to the Lighting tab and create a new lighting settings profile. Turn on Retime Global Illumination and turn off Baked Global Illumination for now, though you can use baked lighting if needed. Drag the directional light into the sun source field under Lighting and Environment and change the skybox to color, setting it to white. Next, create a reflection probe by going to Light, Reflection Probe. Adjust its size and change the type from baked to real-time, setting the resolution to 256. Then create a light probe group to cover the area. Create global volume. Set a profile, either creating a new one or selecting an existing one like the default sample. After selecting the profile, note that changes won't immediately appear in the game view. To fix this, select the camera and turn on post-processing. Now you can customize the settings to match your scene. In the lighting window, generate the lighting. If you encounter black shades, turn off real-time global illumination and generate the lighting again. Now you can see the time and score updating as expected. The game is now complete. Let's make some final adjustments. Go to the prefabs folder and drag both prefabs into the scene. Now adjust the positions of the objects and apply the changes. Set a limit so the bird doesn't go above the screen view. Select the player under Gameplay Objects here. Set the min Y position to -3 and max Y position to 3. Now when you play the game, the bird won't go above the barriers. Select the camera and move it backward. Adjust the positions of the ground. clouds and plants as needed. Now, drag both target objects into the scene to make them a little bigger. And apply the changes. Press play to test. Select Spawn Barriers and set the spawn height range to X, 0 and Y, 0. You can adjust these values to create random height objects. But for now, we're keeping them at 0 because our plants are small. Duplicate the ground object and move it under the gameplay objects. Drag the BG animation script from the script folder onto the ground object. We're creating a parallax scrolling effect for a background. First, we declare a variable called animation speed to control how fast the animation should play. Then, we have a reference to the renderer component called meshRenderer. In the awake method, we get the renderer component attached to the object. If it's not found, we log an error message and disable the script. In the update method, we calculate the texture offset based on the animation speed and time. This offset determines how much the texture should move each frame. We then apply this offset to the main texture of the material attached to the object. If the material doesn't have a main texture, we log a warning message. This script allows us to create a simple parallax scrolling effect for backgrounds in our game. Press the play button to test the game. To build the game for mobile, go to File, Build Settings. Press the Build button. Now, your game is ready to be installed on a mobile device. Thank you for joining me in this tutorial. If you found it helpful, please consider subscribing for more content like this. You can find the complete project on GitHub for reference. The link is provided in the video description below. Feel free to explore the assets used in this tutorial. Don't forget to like, share, and subscribe for more exciting content. Thank you, and happy coding!